12.0 grams of a non-electrolyte is dissolved in 80.0 grams of water. The solution freezes at negative 1.94 degrees Celsius. What is the molecular weight of the non-electrolyte? And for this particular problem, we're talking about a freezing point depression. So we're going to use delta T F is going to equal Kf times m. And I forgot to mention here that Kf is going to be equal to 1.86 degrees Celsius per molal. So in one of the previous videos when we talked about colligative properties, we talked about being able to determine the molecular weight. And this is an example of that type of a problem. So our change in temperature here is 1.94 degrees Celsius, right? That's going to equal the Kf, which is 1.86 degrees Celsius per molal, times the molality. So we can solve here for the molality by taking 1.94 divided by 1.86, which is going to be 1.04, and this is going to be moles of X per kilogram of water. Okay, so we don't know what X is, so I just put moles of X here. We have 80 grams of water, so we can figure out how many moles of this non-electrolyte that we have. So here we have 80 grams of our water solution. We need to convert that to kilograms. We can move the decimal point 3 places, and we get 0.0800 kilograms of water. So our kilograms of water cancel out here, and that gives us 8.32 times 10 to the minus 2 moles of our non-electrolyte, or moles of X. Remember that molecular weight is equal to grams per mole, or has units of grams per mole. Here we start with 12.0 grams of our non-electrolyte. We know that we have 8.32 times 10 to the minus 2 moles. And if we divide that, we get 144 grams per mole for our molecular weight of our electrolyte solution. So anytime we're given one of these colligative properties, and depending on what concentration unit we're given, in this case we're given molality. Most of our concentration units will give us moles of something, or grams of something, and we can convert using the given quantities. So here we have moles of this non-electrolyte per kilograms of water. We know how much water we have. That enables us to calculate moles of the non-electrolyte. Anytime we look for molecular weight, remember it's in grams per mole. So we're given the amount of grams, we determine the number of moles, and that gives us our molecular weight, which in this case is 144 grams per mole.